Hello everyone, good day to you all. Today we are going to see some classification of differential equations. So let's start with order. Order of differential equation is the degree of the highest derivative that occurs in the equation. So for instance, if you have an equation dy dx plus 2x is equals to 0, then the order of this particular equation is 1. Why? Because it is of first derivative. So what if you say d square y dx squared plus 2x is equals to 0? This is a second order. Why? Because it is the derivative, the highest derivative appearing in the equation is just second derivative. So let's say we have 2y prime prime plus 3y prime plus y is equals to, let's say, 10x. So this particular equation, you can see what you can see here, because this y prime prime means second derivative, this is first derivative, and this is just a function of x, which is y. So this is of second order. Why? Because the highest derivative appearing in this particular equation is just what? A second derivative. So this is all about order. Then the degree. So the degree of a differential equation is the highest power of the highest derivative. So for instance, let's say we have y prime prime plus 3y prime plus y is equals to, let's say, 24x. So this is of first degree. Why? Because this is the highest derivative and the power of this derivative is just 1. So for instance, let's say we have y prime prime raised to the power of 3 plus 3y prime plus y is equals to 24x. So then the degree of this particular equation is 3. It's of third degree. Why? Because the highest derivative is second order and the highest power is just 3. So for instance, let's do another example. We have, let's say, y prime 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 plus 4y prime prime plus 2y is equals to 3x plus 2. Let's say this has the power of 4. So then what is the degree of this particular equation? The degree of this particular equation is 1, because of course this has 4 as its own power, but the highest derivative is this one, and the power of this highest derivative is just 1. So the degree of this particular equation is 1. So then whether an equation is linear or non-linear. So an equation is said to be linear if it can be expressed as in this form: an of x, then of y dx raised to the power of n, d raised to the power of n of y dx raised to I dx raised to the power of n, then plus up to the first distance where a n of x, then first derivative, then plus up this, we have plus also, we have 3 dot and plus, and up to s of 0 of x, then first 0th derivative is just y, then is equals to, let's say, a function, let's say g of x. So if you can be able to express a function like this, then that function differential equation is what? Linear. For instance, if you have y prime plus 3x is equals to 0. So how can you be able to express it in this form? Yes, you can say you have what? Dy dx plus 3x is equals to 0. So where this a of x here is 1, then you can say this 0 of x, what do you have? 0 of x here is 3x, then your g of x is what? 0. So that means this equation is what? Linear. But what of this one? If you say y prime y plus 3x is equals to 0, So this can be represented by dy dx, then you have y dy dx, then y, then plus 3x is equals to 0. So then the function should be a function of x, not a function of y. So since it is a function of y, then this is not non-linear. This is not linear. So, and the last part I want to differentiate is either a differential equation is homogeneous or not. So if a differential equation is homogeneous of n degree, if it can be expressed in this form, for instance, it contains it can be expressed as a function of lambda x and lambda y, and this lambda x and lambda y, you can be able to factor lambda raised to the power of some integer where it's still a function of x and y. So let's write an example in it and see. Let's say we have a differential equation f of x and f prime of x comma y, where it is equals to y squared plus 2xy. So this particular equation, we say let's put lambda x and lambda y instead of all this and see what will happen. So in the first one we have instead of this we have lambda x lambda y then squared plus 2 lambda x lambda multiplied by lambda y. So here we have lambda squared into y squared plus we can also factor lambda squared into 2xy. So here we can factor lambda out, lambda squared into y squared plus 2xy. So this particular expression is just your initial function. So that means you can be able to factor lambda raised to the power of n, then a function of x and y. So, and this is, you can call it to be a homogeneous equation of second degree. So this is what is meant by homogeneous equation. So let's look at some examples. So let's look at some question whether we can be able to classify them. So the first one we have here dy dx plus 2x is equals to 0. So this equation, by mere looking, you know it is what, of first order, and it is homogeneous because we can be able to express it in the form we stated before, and it is also linear because there is any y that is multiplying the derivative or the distance. So, and also it is of first degree because the order of the pairs the order of the derivative appearing in the equation is first order. So it's first derivative. So then the second one, let's look at the second one. So we have let's say d square y dx squared plus 2 dy dx plus 3y is equals to 0. So this equation, it's second order, and it is also linear because there is no any independent variable that is multiplying the derivatives, and the degree is 1 because the highest derivative is this and the highest power of this is 1. So, and it is also homogeneous because you can be able to express it in the form that we have already stated before. So, and with this my very simple explanation, I believe you are able to get what we are trying to say. Thank you.